All right, we've got lesson 4.1 and example 1. Remember, our essential question was, how can you derive a formula for the area of a parallelogram? That's what you did yesterday, was to explore a formula for the area of a parallelogram. The target that we're trying to meet once we learn all this is that you can find the area of special quadrilaterals by composing into rectangles. In other words, you can change them into rectangles, and then you're going to apply these techniques to the context of solving real-world and mathematical problems. All right, let's take a look at this picture right here. My question for you is, which has the greater area? Which of these has the greater area? Okay, hopefully you chose the fact that they would be the same. Why? Because of what we did yesterday. We changed this into, in this case, a square or a rectangle. You moved this piece to this piece. If you did that in your head, you would have the same shape. Same shape as this one. So the area is equal. Couple things about a parallelogram. Couple things. When you have a parallelogram, please remember that the side is not necessarily the height. All right? If you were building something and what you were building turned out to be a shape like this, and you needed it to be sturdy so you could place something on top of it, a shape like this is not sturdy because you got pieces leaning. So think of it this way. Whenever you want to do a quadrilateral and build it to be sturdy, you would have to have the height being a straight line. So you have a straight line, that is always the height. Please remember that the height represents the two perpendicular bases. This is a base and this is a base. So the height is between those two pieces. Think of it with a kite. You have a kite in the air and someone asks you, what's the height that your kite is at? Well, you're not going to measure the string because the string is on an angle. That won't give you the height. But if you measure the location of the kite straight down to the ground, that'll give you the height of the kite. Now, we automatically do that. In our heads, we automatically do it. Now we're just seeing it on paper. And the reason you wouldn't measure the string is because, like I said, it's on an angle. We need a perpendicular line. All right, let's take a look at example A. Here is the formula for finding area. A, notice A is capitalized because it's representing a word, which is area, equals base times height, lowercase. The values for base times height can be placed in this algebraic expression, so they are lowercase. In this example, base times height. Base, right here, 12 times height, which is 14, equals 168, and it's 168 square meters. Think of the square. Remember, 168 has that 2 by it for square, that little tiny 2. Think of it this way. In area, right here, we are measuring a two-dimensional object. So you can remember a smaller case 2 because it's a two-dimensional object. All right, let's take a look at the second example. Little different. The base in this case are the two straight lines this way. Now, can you change the object? Can you turn it? Absolutely. But if we look at it this way, we got to look for the two straight lines. Those are your bases. These are not your bases. These are your bases. And then you had to cut the height. In this case, you're going to cut it this way. But remember, we can turn this object. So now you have the formula base times height, 8.5 times 4, which is 34, and the area is 34 square feet. All right, what I need you to do now is this example right here. Once you get to the video here, once you get to the video, follow this, and you can click on the object. Follow it. It will show you a video to check your answer. Make sure you fill in the formula and write the formula. And then you can go to the on your own, and I'll give you the answers when you come back. So you'll pause this video, go into this, and then come back for the answers. All right, the answers for the on your own. First of all, I should see these formulas written on your paper. You don't have this one, but this is the formula you are using. But this is the equation I should see, sorry. Area equals the base, which is 20, times the height, which is 25. Your answer would be 500 meters squared, and yes, you have to have your label. Number 2, here's your equation. It's 126 inches squared. And number 3, 615 yards squared. And that's all for example 1.